Hello my students of 3rd Prep. Today we are going to have a new lesson, which is the relation between two tangents drawn to a circle from a point outside it. Let us start our lesson. What is the relation between the tangents of a circle? You are going to have a theorem which says that the two tangent segments drawn to a circle from a point outside it are equal in length. If you have two tangents as that in front of you, AC and AB, drawn from one point outside the circle, which is A, then their length will be equal. So the given of this theorem is AB and AC are two tangent segments. And I want you to prove that AB equals AC. We are going first to make a construction. Draw MB, MC, and MA. Then try to prove the theorem. Since AB is a tangent and MB is a radius of the circle, so we can say that measure angle MBA equals 90 degrees. And since AC is a tangent and MC is a radius, therefore measure angle MCA equals 90 degrees. Then you have two triangles, AMB and AMC. So in triangles ABM and ACM, or AMB and ACM, it doesn't differ, you are going to notice that MB equals MC equals radius, measure angle MBA equals measure angle MCA equals 90 degrees, and AM is a common side of the two triangles. So we can say that the two triangles are congruent. When the triangles are congruent, then AB equals AC. And in this case, we can say that if you have two tangents drawn from a point outside the circle, so their length will be equal. Some notes you must take care of. The first one says that in the figure opposite, if you have AB and AC are two tangents to circle M at B and C, then we can say that AM is axis of BC, as BD and CD are equal. So the straight line passing through the center of the circle and the intersection point of its two tangents is an axis of symmetry to the chord of tangency of these two tangents. Then what about the other note? Yes, in the figure opposite, you are going to notice that AB and AC are two tangents to the circle M at B and C. And you are going to notice that AM bisects angle A. And this will lead us to measure angle BAM equals measure angle CAM. And also MA ray bisects angle BMC. So we can say that measure angle AMB equals measure angle AMC. This will lead us to what? This will lead us to that the straight line passing through the center of the circle and the intersection point of its two tangents bisects the angle between these two tangents. And also it bisects the angle between the two radii passing through the 2 points of tangency. Now let us have some examples. In the figure opposite to you, I want you to find the values of x, y, and z. First of all, you are going to notice that AB and AC are two tangents to the circle M from a point outside it, which is the point A. So the theorem says that if two tangents are drawn to a circle from a point outside it, then their lengths are equal. So we can say that AB equals AC. Then, since BC equals AC, therefore AB equals BC equals AC. And this means that the triangle ABC will be an equilateral triangle. So in triangle ABC, measure angle A equals measure angle B equals measure angle C equals what? Equals 180 degrees divided by 3 equals 60 degrees. And in this case, we can say that the value of y equals 60 degrees. Then, look carefully. What about AM? Yes, AM is the straight line segment joining a point outside the circle with its center. So this means that AM, that's correct, bisects angle A. So measure angle CAM equals measure angle BAM. In this case, we can say that measure angle CAM equals measure angle BAM equals what? Equals 60 divided by 2 to obtain a result as 30 degrees. And in this case, we can find that the value of y equals 30, asfa. And in this case, we can say that the value of x equals 30 degrees. Then, what about MB? MB is a radius. What about AB? AB is a tangent. So you are going to notice that measure angle ABM equals 90 degrees. Similarly, by the same way, what about MC? MC is a radius. What about AC? AC is a tangent. So we can say that measure angle ACM equals 90 degrees. And in this case, we are going to find that measure angle B plus measure angle C equals 90 plus 90 equals 180 degrees. So measure angle BMC equals 180 degrees minus 60 degrees to obtain a result as 120 degrees. Then, what about angle D? That's correct. Angle D is an inscribed angle. What about angle BMC? Angle BMC is a central angle. And both are subtended by the same arc, which is BC. So we can say that measure angle D equals half measure angle BMC, as they have the same arc BC. So measure angle D equals half multiplied by 120 to obtain a result as 60 degrees. Let us have another example. In the opposite figure, you have measure angle E equals 70 degrees, measure angle BCD equals 125 degrees. And I want you to prove that. First, AB bisects angle DAE. Second, AD is parallel to EB. Now, how can you prove these two requirements? Think carefully. You are going to notice that EA and EB are two tangents drawn from a point outside the circle, which is E. So in this case, we can say that AE equals BE. So in triangle AEB, measure angle A equals measure angle B. How can you find it? It is 180 degrees minus 70 degrees divided by 2 to obtain a result as 55 degrees. And since ABCD is a cyclic quadrilateral. Therefore, measure angle A plus measure angle C equals 180 degrees. As you know that measure angle C equals 125 degrees, so now we can find measure angle A. It is 180 degrees minus 125 degrees to obtain a result as 55 degrees. Yes, what do you notice? That's correct. You notice that measure angle EAB equals measure angle, that's correct, BAD equals 55 degrees. So in this case we can say that AB bisects angle DAE. That's correct. You are going also to notice that measure angle EBA equals measure angle BAD equals 55 degrees, as they are in alternate position angles. So we can say that EB is parallel to AD. Another example. In the figure opposite, try to find the values of X, Y, and Z. First of all, when you look carefully, you are going to notice that AB and AC are two tangents drawn to circle M from one point outside the circle, which is A. So as AB and AC are two tangents, therefore AB equals AC. Then in triangle ABC, what are you going to notice? Yes, that's correct, as it is an isosceles triangle. So measure angle ABC equals measure angle ACB equals what? 180 minus 50 divided by 2 to obtain a result as 65 degrees. And this means that angle ABC is 65 degrees. Then what about angle ABC? Yes, we can now find the value of X. So the value of X will be 65 degrees. Then what about the value of Y? Try to think. That's correct. AC is a tangent and MC is a radius. So measure angle MCA equals 90 degrees. As angle MCA equals 90 degrees, you can now find measure angle MCB. How? Measure angle MCB equals 90 degrees minus 65 degrees to obtain a result as 25 degrees. Measure angle MCB, which is Y. So the value of Y will be 25 degrees. To find the value of Z, try to look carefully at triangle MBC. So in triangle MBC, what about MB and MC? Yes, they are two radii in circle M. So in this case, we can say that MB equals MC equals radius. Then triangle MBC will be an isosceles triangle. So measure angle MCB equals measure angle MBC equals 25 degrees. Can you find the measure of angle CMB? Yes, it's triangle. So the sum of measures of interior angles of this triangle equals 180 degrees. Then measure angle BMC equals 180 degrees minus 25 plus 25 to obtain a result as 130 degrees. So we can say that the value of Z will be 130 degrees. Another example. In the opposite figure, you have angle DMC. Its measure is 130 degrees. And you are going to notice that DC and AB are parallel. AC and AB are two tangents drawn from circle to circle M from the point A. And I want you to prove that CB bisects angle ACD and find measure angle A. First of all, you are going to notice that angle BMD is a central angle and angle BCD is inscribed angle. So measure angle BCD equals half measure angle BMD, which is half multiplied by 130 to obtain a result as 65 degrees, as they are subtended by the same arc BD. So we can say that DC is parallel to AB. Then, since measure angle DCB equals measure angle CBA equals 65 degrees, alternate angles, and since AB and AC are two tangents, then AB equals AC. Then in triangle ABC, we can say that measure angle A equals 180 minus 65 plus 65 to obtain a result as 50 degrees. Another example, in the figure opposite, you are going to notice that AB, BC, and AC are three tangents to the circle. BX equals 3 centimeters, AZ equals 2 centimeters, and BC equals 8 centimeters. And I want you to find the perimeter of triangle ABC. First of all, you are going to notice that BX and BY are two tangents to the circle. So we can say that BX equals BY equals what? Equals 3 centimeters. Now, BC is 8 centimeters. BY equals 3 centimeters. Can you find the length of CY? Yes, that's correct. So CY equals 8 minus 3 equals 5 centimeters. So the length of the tangent segment CY is 5 centimeters. As CY and CZ two tangents to the circle, so we can say that, very good, CY equals CZ equals 5 centimeters. So CZ is 5 centimeters. Then what about AZ and AX? Yes, AZ and AX also are two tangents to the circle. So we can say that AZ equals AX equals 2 centimeters. Now AX is 2 centimeters, BY 3 centimeters, and CZ is 5 centimeters. Can you find the perimeter of triangle ABC? Yes, that's correct. All of you know that perimeter of any triangle is the sum of the length of its sides. So perimeter of triangle ABC equals what? Equals AB plus BC plus CA. What about AB? It is 3 plus 2 centimeters. So instead of AB, we can write 2 centimeters plus 3 centimeters. Plus, what about BC? It is 8 centimeters. Plus, what about AC? It is 5 centimeters plus 2 centimeters to obtain a perimeter as 20 centimeters. Another example. In the figure opposite, AB, AC, and AD are three tangents to the circles M and N respectively. Then I want you to find the value of X and Y. First of all, when you look at circle M, you are going to notice that AB and CA are two tangents drawn to the circle from a point outside it. So we can say that AB equals AC. Then what about AB? It is 15. AC, it is 2x minus 3. Then we can say that 2x minus 3 equals 15 centimeters. So we can say that 2x equals 18, and then we can say that the value of x equals 9. What about circle N? Yes, in circle N, AC and AD are two tangents. So we can say that AC equals AD. What about AC? 2x minus 3 or 15. And what about AD? It is y minus 2. So we can say that 15 equals y minus 2. Can you now find the value of y? Of course, yes. Y will be 17. Another example. In the opposite figure, AB is a common tangent to the two circles M and N. CD also is another common tangent. And I want you to prove that. First, C is a midpoint of AB. Second, AD is perpendicular on BD. Then, first of all, you are going to notice that in circle N, you have two tangents, which are CB and CD. So we can say that CB and CD are two tangents to the circle N, so their lengths are equal. Then CB equals CD. Similarly, in circle N, that's correct. CD and CA are two tangents, so they are equal in length. So we can say that CD equals CA. Therefore, we are going to notice that CB and CA are equal. This means that C will be the midpoint of AB, and this is the first required. Then, to prove that AD is perpendicular on BD, how can you prove such a required? Yes, that's correct. Measure angle CBD equals measure angle CDB, as the two tangents are equal in length. Similarly, measure angle CDA equals measure angle CAD. Then in triangle ABD, ABD is a triangle, so the sum of measures of all its angles is 180 degrees. So we can say that measure angle BDC plus measure angle A plus measure angle B plus measure angle ADC equals 180 degrees. By dividing both sides by 2, you are going to notice that measure angle ADC plus measure angle BDC equals 90 degrees. Therefore, measure angle ADB equals 90 degrees. As angle ADB, its measure is 90, so we can say that BD is perpendicular on AD. Another example, in the figure opposite, try to prove that BC equals DE. How can you prove that BC equals DE? First of all, when you look to circle M, that's correct. AC and AE are two tangents. So, since AC and AE are two tangents, therefore AC equals AE. Two tangents drawn to a circle from a point outside it, then their lengths are equal. Similarly, by the same way, in circle N, what are you going to notice? AB and AD are two tangents. That's correct, two tangents drawn to circle N from a point outside it, then their lengths are equal. So we can say that AB equals AD. AB equals AD, AC equals AE, so by subtracting That's correct. AC minus what? Minus AB is going to be equal AE minus what? AD. So by subtracting, the rest of AC minus AB will be BC, and the rest of AE minus AD will be DE. So we can say that the length of BC equals the length of DE. And in this case, we can say that BC equals DE. By the end of this example, we have reached the end of our lesson today. Thank you for good listening, and bye-bye.